When we designed a hardware VGA controller, we designed some sort of a synchronization circuit that generated an H-sync and a V-sync and all sorts of pixel information. We will need a very similar circuit into our video subsystem, and we were just going to insert it as a core, and generally speaking it will be the last core in the system because the other video cores will be generating the pixels, and then at the very end I'm going to take these pixels, put them through the synchronization circuit, and just send it to the VGA monitor for display. So now we take a look at or an overview of the whole synchronization system. It will be a little bit different than the one we did in hardware because we want something a little bit more general that can, for example, accommodate other resolutions beside the VGA resolution. We will not implement it with other resolution other than VGA, but at least the design will allow you to later on, if you need to, change that resolution. So this is just an overview. We're going to go into the details of each one of these components separately. But for now, what I want you to take a look at is the following. So our system operates at 100 megahertz. That's actually, this is what we call the system clock. However, the VGA system, or the synchronization core, sends the VGA monitor at a different rate. This is what we call the pixel clock rate, and we have computed it to be 25 megahertz. So we have two clocks. So the VGA part is operating at 25 megahertz, and we have the system, the video subsystem, and the whole SoC is operating at 100 megahertz. So what we have is we have two clock domains. And generally speaking, when we have two clock domains, there is a clock domain crossing, and there are some synchronization and timing issues. And over and over, what I've seen is I've seen people basically insert some sort of a buffer in the middle between them so that they avoid any timing issues. And the buffer we're going to be using is the Fifo Buffer because we use it over and over again. However, this Fifo Buffer is a little bit different in that it actually takes a couple of clock signals. So it actually takes the clock signal from one clock domain, and it takes the other clock signal from the other clock domain. It is capable of writing using certain clock and actually reading using a different clock. So we have the 100 megahertz connected to the write, and then the 25 megahertz actually connected to the read part, okay? So we have a FIFO that allows us to do this. So now this actually goes back to the stream processor. Remember, it's like all of we're doing is actually we're taking some pixel data, the RGB, and just basically passing it. And now what we have is we have a FIFO in the middle in here. So now because we use the FIFO and because we have two systems operating at different speeds, we probably need to use, instead of a centralized control flow, we need some sort of a distributed control flow. And the centralized control flow that we had was the global frame counter that was generating an X and Y that was synchronizing all the cores. Now what we need to do, because we have two different domains and whatnot, so we need to actually use some distributed one. And the way we use distributed one is usually we take the global out and we basically create our own frame counter inside. So the global will still be the same. It will actually coordinate between the other cores that are generating the pixels at the 100 megahertz. However, for the synchronization circuit, because it's operating at the 25 megahertz, it's going to have its own frame counter, and it will have a buffer. And the buffer will also actually allow me to get some sort of handshaking signals here and here. And frankly speaking, these handshaking signals would be basically the empty and the full and the basically read and write signals for the Fifo buffer. This is what we're going to see when we talk about the line buffer. But for now, all you need to know is the following. We will be using, at least for the very last core, we will be using that distributed control flow as opposed to the centralized one. So it's a little bit more complicated. That means I have an X and Y in here, and I have another X that's called X core and Y core in here. And like basically part of this synchronization circuit is to figure out when that XC and YC are exactly the same as these. Basically, I just need to know when a frame starts, and we're going to get to the details of that. So let's take a look at the code that actually implements this particular circuit. So the code is really straightforward. It actually goes and instantiate a couple of elements, which is basically the line buffer, which is this one here, and actually instantiate the I'm going to call it the enhanced VGA synchronization circuit here, and just basically connects the signals together. At this point, you don't know how each one of these parts is built, but we're going to get to the details next.